In this video we are going to see about the stack implementation. So stack can be implemented by using two methods. One is by using array and another one is a linked list. So here we are going to see about the stack array implementation. Okay, so in a computer memory, stack can be represented as a linear array. Okay, it can be represented as a linear array. So if you take every stack, it had a variable top. Okay, it had a variable top. So it is used to store the address of the topmost element of the stack. Okay, it is used to store the address of the topmost element of the stack, and it is this position where the element will be added or deleted. So in this position only, what we are doing, we are doing the addition of the element or deletion of the element. Okay, and there is another one variable we are using, that is the max. So it is used to store the maximum number of elements that the stack can be hold. That is, it contains the size of the stack. Okay, it contains the value for the size of the stack. And here, when you are doing the insertion or a deletion, here we have to check the two conditions we have to check. So when you are doing the insertion, we have to check the condition, that is top is equal to max minus 1. Okay, when you are doing the insertion, we have to check this condition, that is top is equal to max minus 1. So why we are checking this condition means, if there is space in the stack means only we can able to do the insertion. So we are checking this condition. And next condition, when you are going to do the deletion, we have to check the condition, that is top is equal to null. So why we are checking this condition means, if some element should be there for doing the deletion, right? So we are checking the condition top is equal to null. So these are the two conditions we are checking here. Okay, and next we are going to see about the operations of the stack. So there is three basic operations in the stack. First one is the push operation. So this push operation is used to add the elements in the stack. It is used to add the elements in the stack. And pop operation is used to delete the element. Okay, pop operation is used to delete the element in the stack. And peek operation is used to, it will return the topmost element. Okay, it will return the topmost element from the stack. So these are the three basic operations we are using in the stack. Okay, so we will see one by one. So first we will see about the push operation. So push operation is used to insert the element in the stack. Okay, it is used to insert the element in the stack, and where we will do the insertion, in the top position we will do the insertion. Okay, in the top position we will do the insertion. So before doing the insertion, already I said we have to check the condition, that is top is equal to max minus 1. Okay, we have to check the condition, top is equal to max minus 1. So if this condition is true means, what it will do, okay, if it condition is true means, what it will do, it will print the message whatever you have given. Based on that, it will print the message stack overflow. It will print the message stack overflow. And if it is false, if the condition is false means, it will execute the else part. So here first what we will do, we will increment the value of the top. Okay, we will increment the value of the top. Then what we will do, we will assign the value. So top of 10 is equal to what value we have given that. Okay, so just for understanding I have written this. Okay, so for example, if you want to insert the element 6. Okay, if you want to insert the element 6, so first what it will do, it will check the condition. So what is the top value? Top value is 4. So 4 is equal to, and what is max minus 1? So the maximum size is 10. 10 minus 1, it is 9. So the condition is false. So if the condition is false means, it will go to the else part, and we have to increment the value of the top. So now what is the top value? It is 4. So now top is equal to 5. So that means the pointer, it will be here in a 5th position. Then what we will do, we will insert the value in the stack. And suppose you think some data are filled, the stack is full, and now we are trying to insert the elements 11. Okay, we are going to insert the element, we are trying to insert the element 11. So first we have to check the condition. So what is the top value? It is 9. Max minus 1 is 9. So now the condition is true. So what it will do, it will print the message as stack overflow. So this is a procedure for doing the push operation. Next we will see the code. So this is the code for pushing the element inside the stack. So you can see first we are passing two arguments, that is st, that is a stack array, then value. Then first what we are doing, we are checking the condition max is equal to, top is equal to max minus 1. Okay, so if this condition is true means it will print the message as the stack overflow. And if it is false means what it will do, it will increment the value of the top and it will assign the value in the top position. So we will see here the same diagram only what we saw in the previous slide. So first we are checking the condition. So top value is 4 and max minus 1 is 9. So this condition is false. So what it will do, it will increment the value of top. So now top is equal to 5. So now this is the top position, and what it will do, it will assign the value 6 here. Okay, so this is about the push. Next we will see about the algorithm. So this is the algorithm for doing the push operation. So first what we are doing, we are checking the condition, what we have done here in the code. So first we are checking the condition top is equal to max minus 1. If it is true means it will print the message as the overflow. Otherwise it will come out of the loop overflow and it will come out of the code, right? Then if it is false means first what we are doing, we are incrementing the value of the top. Then we are assigning the value for the stack. It's simple. The code is simple only. Okay. Then next we will see about the pop operation. So already I said what is the pop operation. It is used to delete the topmost element of the stack. Okay, it is used to delete the topmost element of the stack. So before doing the deletion, here also we have to check one condition, that is if top is equal to minus 1. So minus 1 means null. We are checking top is equal to minus 1. When the stack is empty, okay, when the stack is empty, top value is minus 1. Okay, top value is minus 1. Okay, so if it is the stack, okay, so if it is a if it is this stack, so no element is available, so that time top value is minus 1. So when I are going to insert the element, that first what we will do, we will increment the value of the top. So now what will happen, top value will be 0. So here for doing the deletion, what we are doing, we have to check top is equal to minus 1. If it is true means it will print the message whatever we have given. Based on that it will print the message as the underflow. Okay, it will print the message as the underflow. And if it is suppose if the condition is false, okay, if the condition is false means what it will do, it will decrement the value of the top. Okay, it will decrement the value of the top. Okay, so here, so this is the code for the pop operation. Okay, so we are passing one argument, that is int stack. Then we are declaring one pointer variable. I will say what we are using, why we are using this int val. Then we are checking, first we have to check the condition, right? Top is equal to minus 1. If it is minus 1, so that is if the condition is true means it will print the message as the stack underflow. Okay, it will print the message as the stack underflow and it will return minus 1. If it is false, okay, if it is false means it will go to the else part, and the value which is available in the top, that value was stored in the variable val. It is not required. If you require means you can use. Okay, so what we are doing, we are assigning the value in the top position in the variable val. Then what we will do, we will decrement the value of the top. So now what will happen, the top is 4, the top is 3 now. Okay, then it will return the value. So what is the value here, it is 5, so it will return the value 5. So this is the algorithm. First what we are doing, we are checking the conditions. The same, we are checking the condition. Then if it is false means we have to go to the else part. So first value, so we are storing the top value in one particular variable. Then what we are doing, we are decrementing the value of the top. Okay, we are decrementing the value of the top. So this is about the pop operation. Then next we will see about the peak operation. So then a peak operation, the topmost element of the stack will be returned here. Okay, so the peak operation that returns the value of the topmost element of the stack without deleting from the stack. It won't delete, but it will take the topmost element and it will print the value. Okay, so here you can see top is here, right? So it will, when you are using the peak operation, it will return the value 5. Okay, return the value 5. So here also we have to check one condition, that is top is equal to -1, because if you are going to do the if you are going to return the value of the topmost means some data should be there in a stack, right? So that we are checking this condition. So this is the code. Okay, so first we are checking the condition top is equal to -1. If it is true means it will print stack is empty and it will return -1. And if it is not true, okay, if it is false, so it will go to the else part and it will return the topmost value. Okay, in a top position what value we have assigned, that will be returned here. So this is about the operations of the stack.